Welcome to the new video. In this video, we are going to see how to do the pre-processing of data before building machine learning models. So, before we fit the data to the machine learning model, we need to pre-process the data in order to see whether there is any missing value, whether there is any outliers, whether there is any duplicates value presence in the data, or either there is any garbage values are present in the data. So we need to understand the data first before building any machine learning model. We need to check for the relationship between the data, how the data is related to each other. Then only we can build a best machine learning model. So for that purpose, we need to do the pre-processing of data. So in this video, we are going to see step by step how to pre-process the data before fitting the data into machine learning model. So in this video, we are going to cover the topics like the steps of pre-processing of data. So we start from importing necessary libraries and then read the data set. Then we do the sanity check of the data, and after that, we do the exploratory data analysis to understand the data better. After that, we will do the missing value treatments of data, and after that, we'll do outlier treatments. Then check for the duplicates and garbage value. Then do the treatment of the duplicates and garbage value. After that, let's see what's the normalization, how to do normalization of data and why it's needed. Then after that, at last, encoding of categorical data to fit in the model. So then let's see how to do pre-processing of data step by step. First, I will import all the necessary libraries. So I will import pandas as pd, then import numpy library as np. After that, visualization libraries like Seaborn and Matplotlib. Import Matplotlib plt as Matplotlib pyplot as plt. So first I will import all the libraries. Yeah, my libraries have been imported. Then after that, in step 2, I will read the data to the data frame. So pd dot read. So my data is in csv, so read csv. After that, I will copy the name of the data. So this is data set is about life expectancy data. So I will read that and I will store it in a variable called df. I have read the data to df as a data frame. So if I check for the head of the data, so df dot head, it will show the top 5. So it has the information like country, year, status, life expectancy, adult mortality, infant death, alcohol, percentage of expenditure, hepatitis B, illness, portfolio, like that. Many columns are there in this data set. So this is basically data set of the life expectancy. By having all those columns, we have to predict the life expectancy of the data. So in this video, we are covering the topic only the pre-processing of data before building the model, what the step we need to be taken. So after that, we will fit this data to the model. So I have read the head. Then if I check for the tail, that shows the top bottom 5. So df dot so df sorry so df dot tail, it will show the bottom 5 record. So this is bottom 5 record. So this is how. After that, I will do as a step 3, we have to do the sanity check. In step 3, we will do the sanity check of the data. So sanity check means we will do the sanity check like identifying the missing value, identify the outliers. Is there any garbage values in the data? Is there any duplicates values in the data set? So we will start the sanity check by checking the shape of the data. Shape means how many rows and columns we have. So it's very simple. Df dot shape. If I do df dot shape, it will give the shape of data. So this is my shape. It means 2938 rows and 22 columns of data we have in my data frame. I have 2938 rows and 22 columns I have. So if I check for the information, so df.info, if I give df.info, it will give the information like data types, the column information. It will give the overall information like the entries. So here we can see that it has 2938, whatever is seen in the shape, same information get by the information. It has the 2938 entries indexing from 0 to 2937. So in total it has 22 columns. So all the column information is there in respect of the not null values and d types. So here we can see that it has the columns in total 22 columns each. This represent the not null counts of the data. So here we can see that in total we have 2938 rows. So all here, from here to here, it have the full values, but in this part we can observe some missing values are there. So it also shows the data types of each column. So the country is in the data type of object and the year is in the int form, so that like that all the column information is present. So it will also show here that in my data frame I have the 16 column with the float data type and 4 column with the int data type and 2 columns with the object data type, that is object of country, and the second one is the status. So this is how I can do some sanity check. Then after that, in sanity check I will find the missing value of my data frame. I will find is there any missing value. So for finding the missing value I need to check for df.isNull. So df.isNull dot sum. So before fitting into model, I should make sure that my data is clean. It should not have any missing value. So I need to pre-process the data. In that pre-processing I need to check for is there any missing value. So if I do isNull.sum, it will give the counts of missing value of each column. So here you can find that in country, year and status I don't have any missing value, but in life expectancy and adult mortality we can find that there is 10, 10 like that. In the alcohol it have 194 missing value, and hepatitis B it have 553 missing value. Like that we can find the count of missing value of each column if I want the percentage of missing value. So while doing the missing value treatment, we need to decide whether to do the missing value treatment or to delete the column or to delete the rows with missing value. So we need to decide based on many criteria, based on the number of missing value. If the number of missing value is very huge in any column, we decided to delete that column unless the imputing or the filling with the other value. So first I need to find the percentage of missing value. So by the percentage I can get easy inferences so that I can decide whether to do missing value treatment or not. So I will do the percentage in the different cell. So I will first copy this. So finding percentage is very easy. Control C. If I do this, then Control V, I will divide it by the df of shape. I want one number, df dot shape, in that the first. So this will give the counts of the overall value. So I will multiply this to 100. So it will give the percentage of missing value. So here I can get that in this part it have 0, in this part it have 3% of overall data. Compared to overall data, it have the 3% missing value. In this hepatitis B it have 18% missing value compared to overall data. In the GDP it have 15%. So it's in the minority side, it don't have any 50% missing value. If the percentage of the missing value is above 50%, we decide to delete that column. So here is no problem, there is no any missing value with the more than 50% of the overall count. So this is how we can do the understand the missing value. So after checking for missing value, so we will do the treatment of missing value after in the treatment of missing value. So in this sanity check we will just understand whether we have the missing value or not. So I will do step by step, don't do the missing value treatment here itself because it will create some confusion. So after that, after checking for missing value, I will check for the duplicates. Is there any duplicates in my data set? So while checking for duplicate we need to have the unique value. So if we have the unique value in my data set, then only I can check for the duplicates. Otherwise the duplicate checking is useless, because some besides the unique value. If I have the duplicates, it may be possible. If I have the unique value and then also I have the duplicate, that's the problem. So first I will check for the your purpose. So df dot duplicated. If I do this, df dot duplicated dot sum, it will give the counts of duplicates. So here we can see that it give the zeros. That means I have zero duplicates value. So this is the done with, we are done with the missing value, number of missing value, and also done with the number of duplicates. After that we will check for the garbage value. We will find is there any garbage value in our data set. So the one thing about garbage value is if the garbage value in the present in the any of the column, it is always be in the form of object data type. So if for example if it is the year, if it is in the form of int, so is there any garbage value? If the garbage value is present, is there any special character within this column? The data type will show it as object. Is there any single garbage value? It will show it as object. So garbage value is always in the form of object. So we will check the garbage value in the column where there is the data type of object. So we will do one for loop for count the unique values in the object column. Then we will find whether there is a garbage value or not. So I will use for loop for I in df dot select d types. I include only the object. Include is equal to objects because the garbage value will be in the object column. So object dot columns. So I want this column. After that I will do the value count of that. So df dot I, the value counts of this. So I will print this. So it will give the count of unique value. So if there is any garbage value, it will find that garbage value as a unique and it will print. So I will differ the result. So I will print like the separator. I want it like 10 times. So if I print this, let's see what will we get. So we get the garbage, the values like for the country, it have the, we will find here the Afghanistan, Peru, it don't have any garbage values. So after the status, we have developing and developed. So we will find it over here that there is no garbage value in this data set. If there is any garbage value, it will show it over here, whether it is a star or any special character, it will show it here and it will give the count. So here I can found no garbage value, so I need not to worry about the garbage value. So this is how we can check the garbage value. We can check it by the value count as well as the unique value. Anyhow, if you find any garbage value, we have to do impute or the we have to change that garbage value to the any median mode, anything you want. So make sure that our data set is free of garbage value. So after the sanity check, we will do data exploration, data analysis to understand the data set, the data in my data set. So to understand the data, we will do exploratory data analysis. So how to do that? So first start with the descriptive statistics. So in order to get the descriptive statistics of the numerical column, I just use df.describe. So if I use this code, it will give the descriptive statistics. If I want to transpose, I have to give t. It will give the information like this. It give the counts, mean, standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile, and maximum. By this, we will understand about the number, how the data is distributed, what is the standard deviation of the data. Like that, we will have the many information. If you read all this, we will get to know about how the data is presented, how that is distributed, how the skewness of data, every information you will get the basic understanding of the data, how it is. So this is about descriptive of the numerical column. If I want the descriptive statistics of the object column, so I will use df dot describe, within bracket I have to use include object. So if I use include object, it will give the descriptive statistics of the, sorry, describe, df, sorry, df dot describe, and it will give the descriptive statistic, but in the different way, not as the numerical column information. It will give the counts, the number of values and the unique values. So in country column I have the 193 unique value, means in total I have 193 countries information. In status I have only two values, like developing and developed. So this is how we can inference from the descriptive statistics of the object column. So after that I will do some exploratory data analysis by understanding the distribution of data. To understand the distribution of data visually, we will use histogram. So I can use a histogram. So for drawing histogram for each numerical column, I will use obviously the for loop for each column in df dot select. I will select only, so this is a simple code to select only data types with the, sorry, d types. Include is equal to, sorry, include number. So I just want the column of the numerical data type, so include the number. So if I use column over here, so column, and after that I want to print SNS, that is Seaborn library. I use the plot the histogram, Seaborn histoplot. Seaborn histoplot, within that data is my data frame, and I will give the x-axis as each I means each column of numerical data type, and I will use plt dot show to show every chart. So if I run this code, it will give the result like this. So if I don't want this red color warning, I just use import warnings, import warnings. After that, warnings dot filter warnings. Within that, just use ignore. So by this I don't get that red color warning. So this is how I can get the histogram for each numerical column for the year. I can see it over there, that is constantly distributed. Here I can see the left skewness of the data in life expectancy of adult mortality, right skewness. After that, in the infant death there is very minimal, there is zero, most of the values are zero. After that, in the alcohol, like that, for each numerical column I have the distribution chart. So this is how I can get the distribution. By this I can understand how the data is distributed in my dataset. So this is how I can get the histogram. So this is visually exploring the data. So in exploratory data analysis, we will do histogram to understand the distribution of data, and we will also do the box plot to identify the outlier in the data. To identify whether there is any outlier in the data, we will do the histogram, the box plot. So I will copy the same code and change a little bit. So for the filter, so d types, and here I use the box plot. Just use the box plot for this, and I want to show that, so just use box plot. So I get the box plot for each numerical column. So in the year column I don't have any box plot. So in the life expectancy I have the box outliers in the lower side, and in the adult mortality I have the outliers in the upper side of the data. So in the infant death I have the major outliers, and in the alcohol also I have the outliers. In the percentage expenditure and many column I have the outlier, I can see it by the box plot information. So this is the use of box plot. By this way we can understand about the data, I can understand about the distribution, and I can understand about the outlier of the data. So after that, in order to I will do the scatter plot. So scatter plot is basically for bivariate analysis. It is used to get the whether there is any relationship between the data or not. Is there a relationship between the target variable and the independent variable? So by fitting the model, so we will cover it in the next video, and I will explain just simply over here. So in order to build the model, there should be a relationship between the target variable and independent variable. So here we, in the exploratory data analysis, we will just check whether there is any positive relationship or negative relationship between the data. So in this set, for example, in this data set, here the life expectancy is the dependent factor, all the other columns are the independent factor. By using all the other factor, we will fit the model to predict the life expectancy. So here we have to check the relationship between that. So I have to use the scatter plot to check the relationship. So first I will get the column for the columns. So columns, so I want to get the numerical column first. So d types df dot select d types include is equal to number. So this will give the column of the numerical column only. So I want to get the columns of that, so I will use this the columns. So I will get the columns of that. So by using this I will plot a scatter plot. So for scatter plot I have to use this like SNS. So before that I have to use the for loop for getting the scatter plot for every column. So for each element in, so I have to use a column. So I will first select all the column, then paste it over here. Then life expectancy is my target variable, so I will remove this. Okay, I will remove this, and after that I put it over here. Then for each column in my data I want SNS, means scatter plot. So from Seaborn library, scatter plot data is my data frame. Then the X I will choose the each column. Then as Y I will use a fixed column, that is my life expectancy, that is my target variable. So it will create a scatter plot for this combination like year and the life expectancy, adult mortality and life expectancy, infant deaths and life expectancy, like that. It will create a scatter plot for each combination. So plt dot show. So let's see we will get the result or not. Yeah, we get a scatter plot for the each combination like life expectancy and the year. Then we have the life expectancy and the adult mortality, it have the negative relationship. Then this also showing some relationship over here. Then it have the relationship like this. By this way we can find the relationship. We have to check the relationship before and after outlier treatment. So if we find the relationship is better after the outlier treatment, we will do the outlier treatment. Otherwise we don't do the outlier treatment. We will do fit the model first before the outlier treatment, then we will check for the result of the model, then we do the outlier treatment, then again we build the model. Like that the process will go on. So in this, just see about the relationship to understand the data. So showing some relationship. So this is how the interpret the scatter plot. After that, correlation heat maps. To understand the correlation between the data, we will use the heat map. So df dot, if I use df dot core, that will give the correlation matrix. So here I have could not string. Yeah, I have the that. So I will select only the numerical column. Df dot c. So if I use this, that here, control V and dot core. So let's see. Yeah, we got the correlation matrix of the numerical column. So it will give the correlation. Here we can see the correlation between the data by it ranges from 0 to 1. The above 50 show the strong correlation, of less than 50 show the some correlation between the data. So if I want to plot this in a chart, I will use the heat map to plot that. So I will use sns dot heat map data. So I will select this. I will first store it in any variable, so I will store it in yes. Then I will give the data as my yes. Then if I plot this, let's see what will we get. Yeah, we got a heat map. So if I want the values in the heat map, I have to use a naught is equal to true. If I use that, I will get the values in the heat map. So if I want to increase the size of that, I have to use the pyplot dot figure figure size is equal to, let's give 15 comma 15. So what the wrong plt dot figure fig size, sorry, we have to give it in a bracket. So if I give it in a bracket, let's see. Yeah, we got a heat map with the proper size. In this, I can understand the correlation between, in this dataset, I have the many columns, so it will have the many information. So by this, I can get the correlation, means here this color represent the high correlation, and here we can find the correlation between the each data. So here in this part it have the 8% correlation, then the minus 24% correlation, minus 12% correlation between alcohol and the infant death. So this is how I can get the inferences of the correlation, means the relationship between the data. So we can go through the each column information like this color. I can find the correlation between the data. So if the correlation is good, I can assume that I can predict that my model will give the better result because there is a relationship between the data. So this is the use of the correlation matrix by using heat maps. So this is about exploratory data analysis. So till now we have covered like the sanity check. In the sanity check, we will give the shape. We will check the shape of the data. We will get the information of the data to understand the columns, information, the data types, and all. We will also check for the missing value. Is there any missing value by using df dot is null of sum? Then we will find the percentage of missing value. Then we'll find the duplicates. Then we saw about the is there any garbage value by using the value count. After that we did exploratory data analysis by describe data by descriptive statistics of the numerical and the object columns. Then we plot the data to understand the distribution. We use histogram. Then we understand the outlier in the data. We will use box plot. Then to get the relationship between data, we use scatter plot and the heat map with the correlation matrix. So this is about the sanity check and exploratory data analysis. Then we will come to the step 5, that is missing value treatment. In the sanity check, we find there is a missing value in the data. So in this step, we will treat the missing value. We will treat the missing value in the sense we will fill it with the median mode, or we will use some algorithm to fit it like an imputer to fill the missing value. So by this way we will get the data set without missing value. So that is the necessity. Before fitting the data into model, we need to give the model without any missing value. So that's why we will do the missing values. The decision of the missing values depend on various factors. So let's figure out what it is. Then let's see how to do the missing value treatment. So for missing value treatment, we have the option like we can fill it with the median, mean, or the mode of the data column. Also we have another option, that is on module we have, that is knni imputer to fill the missing value. So it work only for the numerical column. So for the categorical column, we used to fill it with the mode. So we can use both. We can use this median mode or mean method to impute the data, or we can use the kn imputer for the fill the missing value of the numerical column. So I will explain both in this video. So first, if I want to impute the missing value, so first I want to check for the missing value column. So df dot is null sum. We already checked in the sanity check the missing value, the counts of missing value. So I will get it over here itself. So df dot sum, I have the missing value in the life expectancy and adult mortality. So life expectancy and the adult mortality have the missing value. So life expectancy and adult mortality, this column are like numerical but a discrete column. Like life expectancy is the full value. If it is in the continuous data, we can fill it with the median or the mean. If it is in the discrete variable, we have to put fill it with the mode. If it is a categorical column with a missing value, we have to fill it with the mode. So let's see how to fill the missing value. So for that, I need to get the column. So I will get the life expectancy, adult mortality. So in this, for life expectancy, we don't do the missing value treatment because it's a target variable. So while fitting the model, while building the machine learning model, for target variable, we don't do any treatment like missing value treatment or the outlier treatment. We don't do that because it's a target variable. So it will become the artificial data if you do the any treatment on the target variable. So we will skip this life expectancy. For remaining all the columns, we will do the outlier treatment. So while doing outlier treatment, we have to decide whether to fill it with the median or the mode. So for the categorical or the discrete values, we need to fill it with the mode, and for the numerical column, we can fill it with the median or the mode. That is, we need to decide based on the data, the type of data. That depends on differs to data. So that's the individual choice. So here I have to use, first I will show it in median mode imputer, then I will use this kn imputer to fill the missing value. So for some column I will do the medium on mode. So I need to select the column first. So I have to select the adult mortality first. So I will write the for loop. So for each column, for each element in this, so I have to create the list of column. So first I will select this adult mortality. So first I will select the numerical column which I have to fill it with the median. So I will use the not infant death, the percentage of hepatitis B, the miscellaneous, the BMI. So I can use the BMI, body mass index, control C. Then I will use it over here. Then I can use the polio, the number of polio. Let's check for its the type. So for polio we have discrete or numeric. So for polio I can see here it's a it's numerical. So I can fill it with the median or mode, median or mean. So then I will choose the income composition. So this column, control C, and here I fill with. So I have these three columns. So I will impute this with the median. So resources, I will impute this with the median. So df dot that column, df of I means that column, and I will use the fill n to fill the value. We will use the fill n. So I will use the fill n means is there any missing value to fill it with the, we have to give the parameter as the which value we want to fill. So I want to fill it with the median of that. So I will use df of I median. So this will give the median of this column. So median, and I want to make this change in the actual data. So I will use in place is equal to true. So if I run this code, let's see what will we get. So if now I check for the missing value in the life, in the which column we did BMI and polio, like that. If I do now, we can see it over here in the income composition. We have zero null value, we just imputed, and in BMI also we have zero null value, we just imputed. Then in the polio, like over here, the polio, we have zero null value, we just imputed. So by this we impute the data with the median for the numerical. So if I want to impute the categorical data, so here I have the category data, only to country and the status. I have zero null value, no need to impute. If I want to impute, if there is any missing value in this category data, I have to impute with the mode. Just in the place of the median, first select the column. In the place of the median, we have to use the mode and the first mode, because the column can have the more than one mode value. So we have to use the mode of the column, then use the zero index. So it will impute the missing value with the mode of that column. So that's how I can impute with the missing value. So I have another one, this module I have to impute the missing value, that is from sklearn. If I use that, I can do the missing value treatment very easily without any confusion. And so first I need to import that from sklearn, sklearn dot sklearn dot impute sklearn dot import knni means imputed. So after that I have to initialize to impute. So impute is equal to k nni, sorry, I puter. So if I initialize this, so after that I got one error, imputer, sorry, yeah. So after that I will use this to fill the missing value. So after that just need to use the column. So I will use all the columns. So for I in, so I will use all the columns, like for I in df of dot select d types, include all the numerical columns. So I will use include number. So include number, and I want the column of this, so I will use column. So after that impute, I have just imported impute. So df of I means that column is equal to impute dot, we have to use fit transform that column df of I. So let's see what will we get. For run this, I got one error. The impute fit transform df of I need to give it in a double bracket. So if I give this fit transform, so fit transform that column, so here we need to give it in a double square bracket. So df of I. So if I impute this, let's see, yeah, that is imputed all the numerical column with the. So now I check for the null value. I don't have any null value because I just imputed that by using knni imputer. So how this work is, it will take the average of the nearest neighbor. So knni means the nearest neighbor. It will impute, it will take the average of the nearest the value, and it will fill it that missing value with the nearest average of that nearest value. So this is how the kn imputer works. So this is algorithm for the filling the missing value. So it's the best in the industry to fill the missing value of the numerical column. So we can use this to fill the missing value, or if the number of missing value is less, we can also use the median or the mode method. We can also use the kn imputer from the scalar. So anything is okay. So this is how we can deal with the missing value. So now I check for the missing value of my data. It will have no missing value. We imputed all the missing value, all the categorical and numerical variable. So the missing value treatment is done. After the missing value treatment, we have the step 6 of the outlier treatment. So what is outlier? So outlier is the any extreme value, whether it's in upper side or lower side of the data, that's called as outlier. So if your outlier is present in the data, that's not useful for the building a model. So with outlier, the model will won't give the best result. So we will do the outlier treatment. We will cap the outliers with the whiskers or any values based on our decision. So we will fit the model after doing the outlier treatment. So in the pre-processing of data, we need to do the outlier treatment. So for outlier treatment, we need to decide based on the our data. We need to decide whether to do outlier treatment or not to do outlier treatment. It's entirely up to us to while building the model. So here in this video, I will show how to do the outlier treatment. So for outlier treatment, we will first need to define one function to get the whiskers. So after that, so in the box plot, we analyze it that there is a outliers in the data. So here we can see that, like in the here we can see that there is a outlier in the population, there is a outliers in the thickness of in many columns. We have the outliers in the above side and the lower side. So we can cap this outlier to the upper whisker. So this is our upper whisker. So we can cap this all this value to this upper whisker, and if there is any values below this lower whisker, we can cap that to the lower whisker. Means we replace these values with the upper whisker value. So if it is 20 is more than upper whisker, we will fill it with the like 70, like that. We will do the outlier treatment. So let's see how to do the outlier treatment for the data. So and while doing the outlier treatment, we need to keep it in mind that the outlier treatment is done only for the continuous numerical data. We don't do the outlier treatment for the target variable. We don't do the outlier treatment for the categorical and discrete variable. So we need to first figure it out which are the columns are the numerical continuous numerical data. For that column, will do the outlier treatment. So for in this data, for example, for the GDP, it's a continuous data. We can do the outlier treatment for the GDP. Then here we have the more outlier treatment, so we can decide to not to do the outlier treatment. Like that, we have to decide whether to do the outlier treatment or not. So for this video, I will show how to do the outlier treatment. So for total expenditure, I will do the outlier treatment. For the polio, I don't do the outlier treatment as it is discrete. Show the discrete. So for the BMI, you don't have any outliers. For the measless, it have the many outliers. So I don't do the outlier treatment for this. Like that, I have to decide whether to do the outlier treatment or not to do the outlier treatment. But the outlier treatment is done only for the continuous numerical column. So I will do the outlier treatment for the GDP, and the schooling. I don't do the outlier treatment. Then for the income composition resource, it have only one outlier, so no need to do the outlier treatment for that. So for thinness 5 to 9 years, so first need to check for the how the data is present in that column. So for thinness, it have the fractional data, so I can do the outlier treatment for thinness of 5 to 9 and like that. So I will select the three column for do outlier treatment. So just to show how to do the outlier treatment. So for outlier treatment, I have to first get the upper whisker and lower whisker. For that, I have to define one function, that is whisker function. I can give the name as whisker. So in that, I will give the input as column. So first I need to get the quartile. So in order to find the upper whisker and lower whisker, I need to first get the quartile. So I will use the Q1 and Q3, that is 25 percentile and the 75 percentile of the data. So is equal to np dot percentile. So this is a function, percentile function of that numpy library. So np dot percentile, that column, then I want to get the 25 percentile and the 75 percentile of this column. So whatever the column I give to this uh, function, it will calculate first the 25 percentile and 75 percentile and assign it to this. After that, I will find the interquartile range. So interquartile range means Q3 means 75 percentile. That is my Q3 minus Q1. Q3 minus Q1. After that, after getting the IQR, I can find the lower whisker. So the lower whisker is equal to Q Q1 minus 1.5 into IQR, 1.5 into IQR. Then the upper whisker is equal to Q3 plus 1.5 into IQR. So after calculating this, I want to return this. So return lower whisker first, then upper whisker. So let's check whether this execute. Oh, sorry, here I need to give it a thing that. So return. So if I check for the whisker, whether I get the upper whisker, lower whisker. So whisker of, first I need to get the column information, df of. So I will get the columns of each columns. So yeah, I have the column. So I will give the GDP. Where is my GDP? Yeah, this column. If I give this column, so df of this column, let's see what will we get. We got an error because model numpy have the no percentile. So sorry, percent. Oh, okay. Percent n is missing here, so I need to, yeah, it will give the lower whisker and the upper whisker of this GDP column. So this is how I can get the lower whisker and the upper whisker of this. So after the lower whisker, upper whisker, I need to fill it with that. So this is, I just use it to check that whether it is working or not. So after that, I will fill the lower whisker, upper whisker of this three column, whichever I selected. So for I in that column, so first I will select that GDP. First one is GDP. So control V. Then the total expenditure. Control C and control V. Then I will do the outlier treatment for this thinness and this column. So control C and control V. So let's take it over here. So I have this 1 2 3 4 columns to do the outlier treatment. So after that, here I first need to get the lower whisker, comma upper whisker of that column. So for getting a lower whisker, upper whisker, I already defined that whisker function. So I will use that whisker function over here, that, and I will use the df of I over here, means that column. Then after that, I will use the fill that. So I will use df of I is equal to np dot means numpy dot. I will use where to fill it. So np dot where df of I means that column. Check df of I is lesser than lower whisker. Fill it with lower whisker. Otherwise, keep it as it is. So this code tells like that. So if df dot I is equal to np dot where df of I is greater than upper whisker, fill it with upper whisker. Otherwise, keep it as it is. So this is about this code. So if I run this code, yeah, the lower whisker and upper whisker is capped. The outlier is capped with the lower and upper whisker. So if I now check for that box plot again, so let's check for the box plot. So I will use these columns to check the box plot. So control V, so then sns dot box plot. I will directly use that df of I, then plt dot show. Let's see what will we get. Yeah, we got a box plot with no outlier. Before we had the outliers. Now we don't have the outlier because we just did the outlier treatment for this four columns. So this is how we can do the outlier treatment. So the outlier treatment decision is based on the data. It differs to data. We need to decide whether to do the outlier treatment or not. So if I want to do the outlier treatment, we need to decide whether to cap to the upper whisker or whisker, or we need to select a specific value to fulfill that. So it's based on the data. It depends to data. So this is how we can ideally do the outlier treatment by using that upper whisker and lower whisker. So this is about outlier treatment. So then we have the duplicates and garbage values. So we already find in the sanity check we don't have any duplicates value. So we don't have any garbage value also. So we'll skip this. If I had any duplicate value, we need to delete that column by using drop duplicates. To drop the duplicates value, we have to use df dot. So here df dot drop duplicates, df dot drop duplicates. If any duplicates is there, that will be deleted. So in this data frame, we don't have any duplicates, so no need to worry about duplicates. If you have any garbage value, we have to change it to the median or mode of that column. So that's how we will do the duplicates treatment and the garbage value treatment. So at last, let's see how to do encoding of data. So encoding means for fitting the data into model, we need all the columns in the form of numerical. So in my data, we have some columns like here country and the status. It is in the object data form. So we need to convert that object data into numerical. That is called as encoding. So converting the object into numerical, that is called as encoding. So we can do encoding of data in two ways, that is one hot encoding and label encoding. One hot means we will create a dummies for the each category and we will do dummies, and we will also use the label encoding for some categorical data which can be categorical variable which can be ordinal. We can use the label encoding. Otherwise we will use the dummies one hot encoding. So for creating dummies, we have the easy technique using the pandas pd.getDummies. We can use that module to create a dummy. So I have to use the pd.getDummies to create a dummy variable. So I will use like pd dot get dummies. So pd dot get dummies. Within the parentheses, I have to give the data. The data is my data frame. Then I have to give the column for which I need to create a dummy. The column is, I have two column like the country. The first one is country. Then the second column is the status. So status. Then I have to use drop first is equal to true. It will delete or drop the first level, so it won't give the any multicollinearity problem if I drop the first level of the data. So by using pd dot get dummies of this data, and I have to give the column for which I need to create dummy. In my present data, I need to create a dummies for the country and the status, because that only two columns with the categorical features. So if I run this, I have one problem, that is column, sorry, n missing columns. So if I give, it has created a dummy for each country, like country Uruguay, country, like that. It will create a dummies for all the country. So this is how I can create a dummy in a one single code, that is pd.get dummies, and I have to give the dummies. So if I use the categorical ordinal column, I have to use the replace function to replace that the true or false. We can use the label encoding by using replace function. I can give the label like 1 2 3 4 like that. So in this data I don't have any columns which can I do label encoding, so I just did a one hot encoding of this data by using pd.getDummy. So this is how, and I have to store it in a dummy, another data. So this will give the new data, that is dummy. So if I now check for this dummy, it will give all the information in the form of numerical. So I don't have any categorical feature here. So now my data is ready to fit in the model. After this stage, I can fit this data into model, whether it's a regression model by using a scalar or stats model. I can use this data to fill the model. So this is about this video. In this video we learned about many things like pre-processing of data. We learned about how to import necessary libraries, how to read the dataset, and how to do a sanity check to find missing value, outlier, garbage value, and how to do exploratory data analysis to understand the data better, like descriptive statistics. And we will also visualize the data for histogram, box plot, scatter plot to understand the relationship. And after that we did the missing value treatment by mean, median, mode method and knni imputer method. Then we did the outlier treatment by upper whisker and lower whisker impute. Then we did the duplicates and garbage value treatment. Then we did the encoding of data. So this is about this video. In this video we learned about the pre-processing of data. So thank you for watching. Stay tuned for the next video.